In this video, I want to go over talking about how to determine the limit of a composite function. So here's an example. Suppose I have the limit as x goes to 3 of sine, say 3x squared minus 1. This is an example of a composite function because I see if f is defined as sine of g, then the inside function, g of x, is 3x squared minus 1, and I see that this function is f of g, which equals to my sine of 3x squared minus 1. Now, to evaluate the limit, we might want to use substitution method. And it does apply here. So substitution method means that I can just plug that 3 in because this function is continuous and evaluate the limit. And so we get the limit as x goes to 3 of sine of 3x squared minus 1 equals 3 times 3 squared, which is 27, minus 1, which gives you sine of 26, and that's our final answer. But this goes beyond our basic limit laws, because our limit laws deal with polynomials and powers of function, but not composite functions. So what theorem am I using to be able to utilize the substitution method? And the theorem is a nice theorem about composite functions. So let's let h of x be a composite function, f of g of x. And if the limit as x goes to c of the inside function, g of x, equals to, say, some m, and the limit as the outside function approaches m equals some L, then the limit as x goes to c of h of x equals f of the limit as x goes to c of g of x. And what that means, the limit as x goes to c of g of x has already been told to us equal to m. So this would be f of m, or the limit as x goes to m, which means I have the limit must equal to L. So how can we use this in practice? And you'll see 2 homework questions in web work related to this. But let's look at an example that you might have. Suppose you have the limit as x goes to 1 of 3 raised to 4x cubed minus 2. The first thing we have to recognize, this is a composite function. It's a composite function. And it's continuous. Each of the pieces, the polynomial and the exponential, are both continuous functions. And so as a result, those 3 allow us to use our theorem and to use substitution method. Which means we can take this value of 1 and plug that directly into the function to get a result. So we can plug this 1 into that x, and to get our limiting result is 4 times 1 minus 2, 3 squared, and the limit is then equal to 9. So hopefully this helps with a couple of the questions you may have in the homework.